Hello again. Here we are back at the Sandia Mountain Natural History Center, and today we're going to learn about something that we've not talked about yet. Let's think a little bit about what we have been talking about. What's our big concept that we've been discussing? Yep, ecosystems. And what are ecosystems? Ecosystems are places where living and non-living parts are connected, where they work together. Now, these parts, the living and non-living parts, we have abiotic and biotic, don't we? We've learned about the abiotic things just recently in our change over time video. And then we've also learned about biotic parts, things like skulls and scat from our consumers, and things like leaves from our producers. But something's missing. What have we not talked about or learned about? Well, instead of telling you, I want you to pay attention to these next pictures. Make some observations, maybe even take some notes, and try to figure out what this part is that we're going to be learning about today. Now you've taken a look at some of those pictures. What did you notice in those pictures? What were those things? They were mushrooms, that's right. Did you notice anything else in there? There may have been some pictures of mold too. What's the scientific term for mushrooms and mold? I'll give you a little hint. It starts with an F, and it starts with the word fun. Fungi, absolutely. Now what role do fungi play in the ecosystem? If you remember, we had abiotic things, we had producers, we had consumers. Then what was in that other category? That other category starts with a D, and you might be thinking it decomposers. That's right. What do decomposers do in the ecosystem? What's their role? How do they function? Where do they get their energy from? If you're thinking dead stuff, you'd be right. Let's take a look at this dead oak tree right here. There's several things in here you might notice, different colors of stuff. You might notice this whitish stuff here. That's a type of fungi. You might also notice this black stuff, which is also a fungi. These gray things, though, are not fungi. They are lichen. They have a different role in the ecosystem, and we might talk about them another time. Same thing with something down here that you can't see off camera. That is moss. Moss and lichen will also grow on trees when they're living, and they stay on there when they die. Now, let's talk about the fungi here for a moment. This whitish stuff especially, it's the very top of the fungus. We're not seeing the rest of the fungus, are we? The rest of the fungus is inside the dead tree. There's these little tiny white string-like things called mycelium. And the mycelium is the main part of the fungi. The part we're seeing, though, is only the reproductive or fruiting bodies of the fungi. Now, there's one other kind of decomposer that we've not talked about. We can't see it at all with our naked eyes, can we? We can only see it through a microscope. I'll give you a hint if you haven't figured it out already. It starts with a B. Bacteria. Yeah. So fungi and bacteria are the main types of decomposers we like to talk about here at the center. And in a moment, we're going to hear from Stephen, who's going to teach us a little bit more about what happens to dead stuff within the ecosystem.
When animals die, when plants die out here, where do they go? Well, first of all, they're going to fall down to the ground, right? Vince already talked about decomposers. So they take care of all those things. But let's talk a little bit about what happens before the decomposing. So, animal, let's say, squirrel collapses, falls out of the tree, dies, lands right here. It's not going to start decomposing right away. Other animals, like scavengers, might come by and find a free snack. So, a vulture is a scavenger. Coyotes can be scavengers. Those things will eat it. They'll drag it around, might crunch up the bones, maybe not eat everything, leave the bones behind, leave the fur down there. But what they have done is kind of break up that dead animal, that dead squirrel in this case, and scatter it around. Now, when the leaves fall, they land on the ground, obviously. There's a whole bunch of them down here. There's oak leaves, there's pine needles, there's pieces of branch. They're all down here too. They're not starting to decompose immediately, but they will start to break apart. We can say they will start to fragment. A fragment is a smaller piece of a bigger thing. To fragment is to break up into those smaller pieces. What's doing that? Well, there's something kind of like scavengers, but they're called detritivores. Detritivores. So detritivores, well, they're eaters. They are eating things. They're consumers. But they are eating what we call detritus. So all this stuff on the ground, the things that I just picked up, that's detritus. We can use that word detritus in lots of occasions. You have a party, there's a bunch of empty cups, plates, crumbs, napkins. All that stuff is detritus from the party. Well, this is detritus from the forest. Pill bugs, millipedes, those things are detritivores. They live down here in all this dead leaf stuff. We can call it leaf litter. They are eating those dead leaves and pieces of wood and bark and pine needles and breaking them up into smaller bits. That's going to make it easier for the decomposers to start doing their thing, to start decomposing. Not eating, but breaking apart, breaking that stuff down into what we can call the chemical elements that make up all living things. So, a couple kinds of chemical elements would be nitrogen. I think you've probably heard of nitrogen before. Calcium, like in our bones. When those decomposers break down this dead stuff, they're breaking it down and leaving behind matter, and I'll talk about that in a second, in small little bits. And that matter is the chemical elements. Things like I said, the calcium and the nitrogen. Guess what can absorb that calcium and nitrogen now that it's in the ground? The producers, the plants. Let's go back to that word matter for a second. You've probably heard the word matter. States of matter, like water. It can be liquid. If you put it in the freezer, it becomes ice, a solid. If you boil it in a pot, it becomes a gas. States of matter. So everything is matter. What has happened now with the decomposers is that they've transformed that matter into a new state that's available now for all these plants to soak up with their roots. Let's take a closer look at all of this leaf litter in bits and things that we can find if I dig a hole. Alright, so here we are down here low. I'm gonna start moving some of this leaf litter away, but as I do, we can see all these big pieces, full leaves, full pine needles, full sticks. They are slowly being broken apart by those detritivores. In fact, when I scrape some of them away, we can start seeing a darker brown color. This is older stuff down here. Little bits. These are smaller bits now. Broken up pieces of needles and leaves. They are being fragmented. And also, I'm starting to see little white stringy things from the fungus. So we have evidence not only from the smaller bits of the detritivores doing their thing, but of decomposition or decomposing happening. lots of little white strings. As I dig down further, the pieces are getting even smaller. And guess what it starts feeling like down there? It's not dry anymore. It's the opposite. It's damp. Go away, fly. It's damp. We can see stuff that starts to look like what we call compost. Digging down further, what's this? Looks like the little shell of a beetle. Okay? Starting to dig down, and then we're seeing that organic matter, this stuff, starting to taper off. So look at all this stuff. Now, we don't see anybody living in there, but there are living things. If we sat here long enough, we would eventually see little detritivores moving around. Let's cover this back up, let everybody get back to work down there, finish up their decomposing of that section.
Hi, I'm Jim Brooks. I own Soil Lucians. We're a composting facility in the South Valley of Albuquerque. I'm the founder and kind of chief visionary. They call me president. We're recyclers, and we're also bacteria farmers. We're capturing the power of bacteria, which feed on air, water, carbon, and nitrogen. The nitrogen we find in horse manure and food waste, sometimes green leaves, sometimes trees and plants of other types that come in. Grass is another good source of nitrogen. If it's green, if it's brown, it's carbon. So carbon it takes a lot of forms, and it's easy to come by in the desert. A lot of plant material is dry and brown, and that's primarily what we start with here. We grind it up, turn it into smaller pieces, and we mix that with horse manure and food waste. Avocados, bananas, pasta, it's all good. Anything that was ever once alive can be composted here. So as bacteria farmers, it's not just about all bacteria. There's bacteria that does all kinds of specialty work around our world. The bacteria that we're concerned with here are really bacteria and other microbials, really small things that you can't see, and it's a special kind of bacteria that likes heat, because when we pile these things up and the bacteria eats the food that they require to replicate, then they release heat. Well, that heat gets captured in here, and there's only certain bacteria that can handle that, and we call them thermophilic bacteria. That's heat-loving bacteria. So a lot of bacteria, like in our bodies, it's going to be dead as soon as you start to run a fever. You get over 98, you get 100 or 101, a lot of bacteria dies that are bad for humans. But in a composting process, that bacteria that can handle, say, 130, 140, even 150 degrees. Some of our piles start off as high as 156 degrees Fahrenheit. So those bacteria are responsible for the heat that we have inside of this compost pile here. This is pretty warm. It's been composting for nearly 2 years, and it's about 124 degrees. There's about a foot inside of the pile, and there's this gray material. It's a particular kind of bacteria called actinobacteria that's eating the wood. Now, we can't see the individual bacteria. They're too small. You'd have to have a microscope to actually see that bacteria, or the colony of bacteria as it is on a piece of wood such as this. But you don't see mushrooms. You don't see pretty much any of the decomposing bacteria and microbial life that you might see on a forest floor. If you were at the Sandia History Center, Sandia Mountain History Center, you might see a forest floor that has similar attributes, but it's not hot. So how come we don't see mushrooms as a decomposer, for instance? Right? We may have mushroom spores in here, but they're not going to thrive yet because it's too warm, right? They're going to want ambient temperature. They're going to want something closer to 50 degrees, maybe 60 degrees. When the soil's too warm, mushrooms don't do great. They like it cool. And they like a lot of material, a lot of organic material, and a lot of cover. And you'll see the mushroom head stick up, but underneath might be miles of little strands of mycelia. They're great decomposers. They'll work in your backyard. They're not going to be in a commercial compost facility such as this. Maybe after you put the compost in your soils and a year later you might get mushrooms, but not while it's actively decomposing.
So we have an activity for you to do that's all about decomposers. It requires just some simple things from home. Food scraps and some plastic bags. They can be Ziploc bags like this. They can be food bags, bread bags. You just need to be able to close it up somehow. All right? So, two things. A bag that can close up and some food scraps. Here's some that we use to start ours off with. We have orange peels and some beans and chicken leg. They're all very different things. Now we're keeping them sealed up in here so the moisture stays in there, and also so the smell stays in there, because we know that rotting things start to smell. You're going to keep an observation log again. This one looks a lot like the change over time one. 4 columns. First one has the date, and then the other 3, each one is for the food item that you're going to use. If you want to do more, that's fine. Just turn the page and make more columns. The dates are obvious. What you're going to put, though, for each line going across on each date for the food items is how they've changed. So the first day, on mine it was April 26th, is when you put it in the bag. There should be no mold on it. So write that down. No mold. No mold. No mold. Every day after that, when you check it, make sure you put the next date and then say how it's changed. If there's no mold on it, just say there's no change or there's still no mold. If water ends up in the bag, like on the surface of the bag from the moisture in that thing, put there's condensation on the bag. That's what I did for the chicken bone on the second day. You can have a number of days go by. It doesn't seem like they change at all, and that's fine. The first change that I saw started happening was the juice with the beans started turning a yellow color. So guess what I wrote down? Yeah, I put the bean juice is turning yellow. It took a few days for some mold to show up on the orange peels, and even more days for the mold to start forming on the chicken leg. So by the time I finished, which was not quite 2 weeks later, the chicken bone was covered in mold. The beans, it looked like yellow snot. So guess what I wrote down on my observation log? Yeah, I said that the bean juice looked like it's snot. It was a good word to use. So here's what they look like now. We'll start off with the orange peel. You guys have seen moldy orange peels before. Here's the snotty beans. Yeah, doesn't it look like snot? Yuck. I never opened it. I'm not going to open it. It probably smells worse. But here's the chicken leg. I had to open this one because we couldn't see it. There's so much mold on it. But check it out. It looks like it has hair. So what kind of description can you give it? Yeah, you can say it looks like it's covered in hair or fur. But it's just mold. And this one, it really smells. So I'm going to get this back in the bag. All right, so your observation log. Make it go for maybe about 2 weeks. For sure you have to keep observing until you start seeing that mold growing in there, whether it's liquidy or hairy, like on the chicken leg. And check it every day.
Here's one last thing for you to think about. What would the world be like with no decomposers?